Okay, so we're recording this. So we're recording the practice set on probability for November 10th. And Teddy, thank you for reading number one. So basically, number one's asking us what is the increase in the total number of graduates in the in 5 of these mag schools in District 1 from 2013 to 2014. So obviously we have 5 different schools, or 5 different programs, it looks. Yeah, it's 5 different schools actually, never mind. So how would I go about calculating this, Teddy? What do you think?
I mean, you could like add them up.
Yep. Yeah, just add them up. Right, it's that simple. You just add up the 2013 column, add the 2014 column, and just take the difference, exactly. So you know, if I do that really quickly here, 120 plus 146 plus 84 plus 163. And actually what I could do to make your life a little easier, you could actually just take the difference. Like that's the difference of -5, that's the difference of 5, that's the difference of 20, that's the difference of 0, and that's the difference of 5. Add all up, and the difference is 25. You can just do that too. That's just easier that way. So the answer would be A. There's a question in the chat. Oh, no worries. If you have to use the bathroom, go ahead. Okay, so Mel, I'll have you help me with number 2. Do you want to read number 2 for us, Mel? You just read it from my screen. Mel, are you there? Okay, looks like Mel's not there. Ada, I know, went to the restroom. Izzy, can you read number 2, please?
I can do it.
Oh, Gabby, you want to read number 2? Okay, why don't you read number 2, Gabby?
Okay. Many people shop online primarily because they get access to product ratings submitted by fellow shoppers. The frequency table above gives the most recent 20 customers' ratings for a certain product sold online. What is the mean rating for this product?
Great, thank you, Gabby. So this has nothing to do with what we just did today with two-way tables, but it's still kind of good to talk about. Let's take a look at Amazon.com. So you can see I went straight to TI calculator, but let's say something that I have to buy often because I have kids. So diaper genie, okay. And I'm curious about the rating. So this has really good ratings. Like this is like 4.6 out of 5 stars, right? And 502 people rated this. So maybe I want to buy that item, right? But how do they calculate that rating? So they do a 5-star rating. So some people gave it 1 star, some people gave it 2 stars, some people gave it 3 stars, some people gave it 4 stars. Majority of people gave it 5 stars. But how is that exact? How did they get 4.6? How did that happen? So we're going to do that right now. So so Gabby, help me out here. So how many people gave a rating of 1?
1.
1 person. So you do 1 times 1. Now, how many people gave a rating? I'll do a different color now. How many people gave a rating of 2?
3.
Exactly. So frequency means the number of people, or how often it happens, right? So 3 times 2. Let's keep moving here. How many people gave a rating of 3? 5 people. And then, Gabby, how many people gave a rating of 4?
5 people.
5 people. 5 times 4. So think of that as being worth 20 points, right? Like, wow, now 5 people gave a rating of 4. And then how many people gave a rating of 5, Gabby?
6 people.
Right. And then if we add up this entire row, this tells us how many people were involved. How many people were involved? 1 plus 3 plus 5 plus 5 plus 6. So it's a total of, if you add it up, that's 20 people. Well, they just said 20 people, duh. So you add all this up and divide by 20. So if you add all that up, that's going to be 1 plus 6 plus 15 plus 20 plus 30 over 20. So that's 22, 42, so 72 out of 20. And the rating becomes 3.6 if you were to punch in the calculator. So that's how to calculate like those ratings on Amazon or Yelp or Google reviews or like TripAdvisor if you're looking for a hotel or like a good restaurant to eat at or something like that. That's how that's calculated, just so you know. Okay, cool. Well, thank you, Gabby, for that. Aiden, are you back? Okay, Aiden's not back, so let's see. Zach, can you read number 3 for us, please?
Yeah. Phase 1 clinical trials are run to determine the safety of all new drugs, especially with respect to the severity and duration of side effects. A physician is overseeing a phase 1 trial based on 800 healthy participants. Half of the participants are given the drug and half are given the inner pill. The mean duration of side effects for those participants who were given the drug was half. What? I can't really read that.
Well, sorry, it was 72 hours.
Oh, okay. 72 hours with a margin of error of 6 hours. The physician is planning to replicate the trial and in an attempt to decrease the margin of error. Which of the following will most likely lead to a decrease in the margin of error for the mean duration of side effect?
Okay, so 800 people were part of the study. And I'm not sure if you guys followed the news yesterday, but does anyone know what the big news was from Pfizer about the vaccine? Does anyone want to
Didn't
share?
their vaccine get like 90% effective or whatever?
Exactly. And when they say 90% effective, like, did you figure? Do you know more details of how they did it, or like what exactly was done in the study?
I do not.
So what they did was they did something called a placebo, which we'll talk about later in this class. A placebo means that they were given a pill that did nothing. That's what inert means. Inert means so basically like does nothing. So because then you're curious, like, does someone get better for another reason, or was it really because of the pill? And they noticed that 9%, I think I have this right, that 9% of people that received the vaccine actually saw improvement from their COVID symptoms, or just did not get COVID. I have to double check. Well, thanks, Aiden. So that's what's kind of happening here. So it's something that happens all the time. This is actually very, very relevant. And, obviously it's making big news that Pfizer's done it, and hopefully it'll become more widespread, or they'll get approved from the FDA. But of course, you want to make sure that these are reliable results. Like, what if they only had like 40 people in the experiment? Like, that seems kind of small number of people. And they do say there's a margin of error to the study. So you want to reduce the margin of error. So Zach, what do you think we would have to do to decrease the margin of error, to make our results more reliable? Should we have more people participate, or have fewer people participate in the study?
I mean, I don't think I understand what the margin of error for 6 hours is. Like, what is that for?
What that means is that so they ask people like how long they had side effects, right?
Yeah.
So 72 hours was probably the mean. The margin of error, actually, we haven't done that yet. We will do that later on, but basically, they're not 100% sure if it's 72 hours. Like, maybe some people had it for 78 hours, or maybe some people had it for 6 hours. So that seems to be a pretty wide range.
Yeah.
Narrow that gap.
Probably to increase the trial size.
Yeah. The more people you have, the more reliable your data will become. It's kind of, I'll give you a good example. A good example would be if you surveyed people who are they going to vote for in the election, right? Biden or Trump. And of course, we won't get political, but Biden's been declared the winner. And I think Biden got about 51 to 52% of the popular vote, maybe a little less than that, and Trump, a little bit under 50%. But what if you just surveyed just like 20 people in Redwood City? Like, probably 18 or 19 of those 20 people probably will. Okay, I don't want to get political. Most of the people probably would say Biden, right? Where if you went to like a red state, like say Alabama or Kentucky, they probably would say Trump. So, but what if I asked 10,000 people and ask them in different parts of the country, then would I get something that's a little more reliable? I would have, so that's kind of the margin of error. That's what that would be decreased, because I'd have results are more reliable. And we're going to talk about that kind of stuff. This is what we call sampling and how to actually do surveys correctly. That's what we're going to do when we come back from Thanksgiving. We're going to do that kind of stuff. So that's what's going on with that one. So thank you, Zach, for helping us there. Going on along the same lines, Will, I see you next. How about number 4? Do you want to read number 4 for us, Will?
Sure. In a survey of 1,600 adults in the United States, 48% indicated that television is their primary source of news. The margin of error for this survey is plus or minus 2.5%, which value is outside the interval that is likely to contain the exact percent of all adults in the United States who get the news primarily from television.
So don't overthink this problem. All this means is 48 plus or minus 2.5. So it means that it could be 50.5% all the way down to 45.5%. And margin of error, again, and Zach, you asked a great question, like, yeah, of course you don't know how to calculate because I haven't shown you or taught it to you. But we are going to do that probably in January when we come back from Christmas break, or sometime in the second semester. And what we're going to do is we'll do something called confidence intervals. And you could say, like, hey, I'm 95% confident that, that people watch news in this range, or something like that. But anyway, which values outside that interval? It's pretty obvious 45 is outside that interval. So the answer is A for that one. Let's start getting into stuff on two-way tables. So I'm actually going to jump, because I kind of want you guys to start doing stuff on two-way tables. Maybe we'll do 15 and 16. Then I'll have you guys do 19 and 20 in groups. Let's take a look at 15. John, do you mind reading number 15 for us, please?
The table above summarizes storm activity in the Atlantic Ocean between 1990 and 2009. What portion of the storms between 1990 and 1999 were classified as major hurricanes?
Great, thank you so much. So notice we have 4 categories of years. We have the early 90s, the late 90s, the early 2000s, and late 2000s, right? And we had 3 categories. We had a tropical storm, a hurricane, and a major hurricane. Major hurricane being anything that's category 3 or higher. So they said that of the storms between 1990 and 1999, so it means I have to focus on these storms. Now, John, how many storms were there from 1990 to 1999?
110.
Total 110 storms. Thank you very much. Now, of those 110 storms, how many were classified as major hurricanes?
64. Oh, wait, 25.
Exactly. So you did regular hurricanes, but we were on major, right? So it's really about wording more than anything else. So it's 25 out of 110. And then you just punch in your calculator and you get the answer. And so we get 0.227. So the answer is C. So it's not that hard. That's all that's really happening there. Just reading tables. And that could be kind of interesting, because then maybe, has the rise of major hurricanes increased later in life with more climate change? For example, in the late, from 2005 to 2009, that'd be 18 out of 78. And it's actually slightly higher, it's about 23.08%. So maybe that's not really significant increase, but those are things that we'll talk about in the second semester about significance and where stats are statistically significant. And then let's see if someone else could help me out here. Aiden, can you help me out with 16 if you're back?
Yeah.
Yeah, go and read 16. And we'll do a breakout room after that.
Okay. The students in an environmental science class will be randomly assigned to a storm to research, with no two students researching the same storm. Given that the students will each be assigned a hurricane or major hurricane for the reports, what is the probability that a student will be assigned a storm that will occur prior to 2000?
Great. Thank you. So yeah, so they said a given. So you have to always look for the given or considering, blah, blah, blah. So it's all about wording, really, anything else. So what's the probability, given that a student will be assigned a hurricane or a major hurricane. So only focus on, so I don't care about this. So you can cross it off, only hurricanes and major hurricanes. So first of all, how many, so I'm looking at this data. Or actually, I don't know why I'm highlighting all that. That's kind of dumb. Hold on a sec. Just let's see, let's undo.
I think it's, I don't know if I'm right now because I can't really see. Is it 15 or 16 for the first tropical storm line? Oh, wait. Yeah. That's total.
It's 6, but we don't care about tropical storm.
No, yeah, okay. Yeah, well, I was just subtracting the amount. So any storm before 2000 would be 23, 41, 5, and 20.
Yes, good. So basically what Aiden's doing is that, well, first off, how many total hurricanes or major hurricanes were there in our data set?
175.
Plus 74.
Yeah.
Yeah, so the total is 175 plus 74. That goes in the bottom. But then what do we want? We want prior to 2000. So how many are prior to, so you were correct.
So
these are all prior.
I don't know if it was 99. I don't know if I did the math right on that.
Actually, you're just going to be, actually, you're probably right. Yeah, because you would do 110 minus 21. I think it's 81.
89. It might be 89.
Let's see, 64.
89.
Yes, 89, yes.
89 over 249.
Yes, very good.
Which is 0.357. So
there we go. That's all. Yeah. So don't overthink those problems. They're really, really straightforward. Okay. So I'm going to have you guys work on, some of these problems are a little funky, but I'll have you guys do, let's try to think here. What's the probably good problems to do? Give me a sec. Maybe we'll just do the last. I kind of like some of these other problems too. Maybe we'll do 11, 14, I don't know. Well, definitely 19 and 20. Yeah, 17 is probably good too. Yeah, let's do 17, 18, 19, 20. How about that? So we'll do 4 problems. We'll do this for about 10 minutes. Then we'll come back. So again, to access this, you simply go to, okay, we don't care about diapers anymore. Just practice set probability. It's right there. So practice set probability is right there. Yeah. So I'll put you guys in breakout rooms for about 10 minutes. Again, you're doing 17, 18, 19, and 20. 17, 18, 19, and 20. So let me stop sharing. And we lost 2 people. I wonder who did we lose here? We lost Riley and
Riley said that her Wi-Fi kept messing it up, so I didn't realize that she left, but she told me to tell you.
Got it. And then, but who else are missing?
She left that it's because of her Wi-Fi. And
no worries. And we're missing
I think Izzy.
Okay. Well, anyway, let's do breakout rooms. So let me do that right now. So I'll create 3 breakout rooms. Let me just assign them right now.